The second factor that is influencing the strength of concrete is gel space ratio. In the water based cement ratio, we have seen that Mr. Abraham has given an equation to find out the strength of the concrete based on water based cement ratio X. But it has certain limitations. Okay, because while giving this equation, Mr. Abrahams has considered that the water based cement ratio is the only factor that is influencing the strength of the concrete. That is what he has taken. But in fact, not only the water based cement ratio that is influencing the strength of the concrete, there are other factors also, such as first one, the degree of hydration of cement. How much amount of cement is hydrated at that particular instant of time, and the temperature at which the hydration is being taking place. What is the temperature while this concrete is hardening? And next, the air content in case of air entrant concrete, and the formation of any fissures or cracks due to bleeding and shrinkage cracks. So these also influences the strength of the concrete and not only the water based cement ratio. So therefore, this equation which is given by Abrams is not that accurate in the calculation of strength of concrete. Instead of relating the strength to water by cement ratio like Mr. Abraham has done, what we are going to do is we are going to relate the strength of the concrete correctly with the solid product of hydration of cement gel to the space available for the formation of this product, that is gel space ratio. Um, this could be understood by this following figure. See, in this figure, initially this is the cement and this is the water. This is water and this is cement. And the cement particles are reacting with water with the time, and therefore this is how it reaches to B. See, this is the unhydrated cement particles, and here this is the hydrated cement gel, and this is water. So with respect to time, what happens is more and more cement particle are going to come in contact with water and going to hydrate. In the process, it reaches stage D. And what happens here is there are going to be some pores. These are capillary pores or simply cavities. And what does these contain? These contain water. Okay. And here there is still cement left to get hydrated. To get hydrated. And here you can find hydrated cement gel or cement gel. So now let me consider this volume of hydrated gel divided by volume of hydrated gel plus volume of capillary pores is nothing but gel space ratio. సో జెల్ స్పేస్ రేషియో ఎందుకంటున్నామంటే న్యూమరేటర్లో ఉంటే చూడండి వాల్యూమ్ ఆఫ్ జెల్, కింద డినామినేటర్లో ఏముందంటే total volume of the gel that can be produced. This water in the capillarities come in contact with the cement and get hydrated and form the cement gel. సో ఒకవేళ 100% ఇది ఫామ్ అయిపోయింది అనుకోండి, అప్పుడు వాల్యూమ్ ఆఫ్ హైడ్రేటెడ్ జెల్ డివైడెడ్ బై వాల్యూమ్ ఆఫ్ హైడ్రేటెడ్ జెల్ అవుతుంది, ఎందుకంటే పోర్స్ ఇంక ఉండవు కాబట్టి. అప్పుడు జెల్ స్పేస్ రేషియో ఏమవుతుంది? 1 అవుతుంది ఇఫ్ ఆల్ ది సిమెంట్ పార్టికల్స్ ఆర్ హైడ్రేటెడ్ అండ్ దెర్ ఈజ్ నో పోర్స్ అయితే. ఓకే, సో నౌ we are saying that the strength of the concrete is dependent upon gel space ratio. Therefore, the gel space ratio is given by volume of hydrated gel divided by volume of hydrated gel plus capillary pores in gel. So here Mr. Powell and Brownyard has established a relation between the strength and gel space ratio and he has given an equation of 240 x cube. 240 x cube. So this is the relation between strength and gel space ratio x. And 240 is the strength of the gel itself, only gel. Okay, but here S represents strength of concrete. Strength of concrete. So for gel space ratio, for complete hydration, if the complete hydration is taken place, the volume of the gel divided by space available will be this. This is the expression for gel space ratio, where C is the weight of the cement and W naught is the volume of water that you have mixed initially, and this hydration is partially completed. అంటే మొత్తం సిమెంట్ అంతా కూడా హైడ్రేట్ అవ్వలేదు అని అనుకుంటే ఆ పర్టికులర్ కేసులో జెల్ స్పేస్ రేషియోని ఈ విధంగా ఈ ఈక్వేషన్ వాడు చేయాలి. ఇక్కడ ఒక ఫ్యాక్టర్ ఆల్ఫా అనేది ఎక్స్ట్రాగా వస్తుంది, దట్ ఈస్ ఫ్రాక్షన్ ఆఫ్ సిమెంట్ దట్ ఈస్ హైడ్రేటెడ్ అమౌంట్ ఆఫ్ సిమెంట్. ఐ మీన్ ఇఫ్ ఐ సే దట్ 60% ఆఫ్ సిమెంట్ హైడ్రేట్ అయితే వాట్ ఈస్ ది స్ట్రెంగ్త్ అని అడిగాను అనుకోండి. సో వాట్ యూ నీడ్ టు పుట్ ఇస్ యూ హ్యావ్ టు ఫైండ్ ఎక్స్ దట్ ఈస్ జెల్ స్పేస్ రేషియో ఫర్ 60% ఆఫ్ హైడ్రేషన్ ఆఫ్ సిమెంట్, అంతే కదా. అంటే ఇప్పుడు ఎక్స్ అనేది ఈ వాల్యూ యూస్ చేసి ఫామ్ చేయాలి. ఇందులో ఆల్ఫా ఏమవుతుంది 60% కాబట్టి 0.6 అనమాట. సో ఇప్పుడు నాకేమొస్తుందంటే జెల్ హైడ్రేట్ అయిన సిమెంట్ 60% అయితే స్ట్రెంగ్త్ ఎంత అంటే స్ట్రెంగ్త్కి పర్సంటేజ్ ఆఫ్ సిమెంట్ హైడ్రేటెడ్కి కూడా మనం ఇక్కడ రిలేషన్ తీసుకురాగలుగుతున్నాం అనమాట ఇక్కడ. ఓకే, సో how does this gel space ratio influences the strength of the concrete? So we know that compressive strength of the concrete is found to be severely. So how does this gel space ratio influences the strength of the concrete? We know that compressive strength of the concrete decreases with the increase in porosity. Porosity increase అవుతున్న కొలది అంటే వాయిడ్స్ అనేవి ఇంక్రీజ్ అవుతున్న కొలది కాంక్రీట్లో స్ట్రెంగ్త్ తగ్గుతూ ఉంటుంది అన్నమాట. బట్ దిస్ porosity is dependent upon gel space ratio. Okay, so compressive strength is related to porosity and porosity is related to gel space ratio. Okay, so a higher gel space ratio reduces the porosity. So if the gel space ratio is high, porosity decreases and this leads to compressive strength increase. Similarly, if the gel space ratio decreases, the porosity increases and the compressive strength decreases. And this graph here helps us to understand the manner in which this gel space ratio influences the strength of concrete. So this is the graph that is obtained by calculating the strength of the concrete cubes of 50 mm size, and this is the gel space ratio. So as you can see, when the gel space ratio is increasing, the compressive strength of the concrete is increasing.